Section 8, Inequalities. We're going to look at a method for solving polynomial, rational, and trig inequalities. The method's explained in the packet, and I think it'll make the most sense just to go through an example and kind of walk through that process with a specific example in mind. We're going to start with a polynomial inequality, and we're going to look at x minus 3 times x minus 2 is less than 0. The first thing we need to do is find what are called the critical values. These are values that either make our expression over here 0 or undefined. So really, I'm just going to set my two pieces equal to 0. And I'm going to get critical values at x equals 3 and at x equals negative 2. I'm then going to plot those critical values on a number line. These critical values have divided my entire real number line now into three different sections. A section before negative 2, a section between negative 2 and 3, and a section from 3 on. The way this will work is the signs of this expression can only change at negative 2 and at 3. So for example, if I figure out that by plugging in 0, I get something negative, that means any number you were to plug in between negative 2 and 3 would give you something negative. What I'm going to do to determine the signs of my regions is I'm going to plug in a test value within that region, see what sign I get, and then just label that region by that sign. First, I'm going to plug in x equals negative 3, because that's a good test value before negative 2. Plugging in negative 3, I get x, no I don't, I get negative 3 minus 3 times negative 3 plus 2. That's negative 6 times negative 1, so that's positive 6. I don't even care about the 6 part so much as the fact that it happens to be positive. Any number you plug in that's before negative 2 will give you something positive when you plug into that expression. Between negative 2 and 3, I think 0 would be a good test value. I get 0 minus 3 times 0 plus 2. That's negative 3 times 2, or negative 6. Again, I don't care about the 6 part so much as the negative part. Any number you'd plug in between negative 2 and 3 would make that expression negative. Then, plugging in something after 3, like x equals 4, would give us 4 minus 3 times 4 plus 2. 1 times 6 gives me 6, which is something positive. Plugging in any number before negative 2 would give you something positive. Plugging in anything between negative 2 and 3 would give you something negative. And plugging in anything from 3 on would give you something positive. Now, going back to the original inequality, I was looking for the x values that you could plug in that would make the expression less than 0, or negative. All I need to do now is just pick out the negative region, or negative regions. In this case, it's all the values between negative 2 and 3. Using my interval notation, I'm going to say that the answer is the region from negative 2 to 3. Looking at another polynomial inequality, let's take a look at x to the 4th plus 13x cubed plus 40x squared is greater than 0. To be able to make some sense out of this, I need to factor it. So I'm going to say x squared times x squared plus 13x plus 40 is greater than 0. X squared times x plus 8 times x plus 5 is greater than 0. And setting all the parts equal to 0, I'm getting critical values at x equals 0, negative 8, and negative 5. I'm going to go and plot those on a number line. For my test values, how about I plug in negative 9, negative 6, negative 1, and positive 1. I'm going to plug into the factored version. When I plug in negative 9, I get negative 9 squared times negative 9 plus 8 times negative 9 plus 5. Now, realize that I don't actually care about the number, I just care about the sign of the answer, so I'm just going to sort of work with my signs rather than actually dealing with specific numbers. I know that negative 9 squared is a positive number, so I'm going to say I have a positive times. Negative 9 plus 8 is a negative number, and negative 9 plus 5 is a negative number. A positive times a negative will give you a positive. My first region is positive. Plugging in negative 6. Negative 6 squared times negative 6 plus 8 times negative 6 plus 5 gives me a positive times a negative, which makes my second region negative. Plugging in negative 1. Negative 1 squared times negative 1 plus 8 times negative 1 plus 5 gives me a positive times a positive times a positive. So that next region is positive. And finally, plugging in 1, we get 1 squared times 1 plus 8 times 1 plus 5. That's again a positive times a positive times a positive. So that region is positive. To finish this off, I was looking for greater than 0, so I was looking for positive regions. I have 1, 2, 3 positive regions over here. I'm going to say that my answer is negative infinity, comma negative 8, union negative 5, comma 0, union 0, comma infinity. I don't want to make my last region just negative 5 to infinity, because when you plug in 0, you would get 0 over here, so technically 0 should be excluded.